Hello, class. This is Doug, and college algebra or math 1220 is what we're going to do today, quadratic functions. So let's get started with this exciting stuff. Okay, so uh, we know from transformations, we talked about transformations before, what this function will look like. So we're given this function right here. Remember, this is in transformation form. That's a vertical stretch. And what do you do with that vertical stretch? You multiply all previous y coordinates by that number. So since it's bigger than 1, that'll make the parabola taller and skinnier. Isn't that a horizontal shift? And that's a vertical shift. And by the way, this is like h and that's k. And that's also the vertex. So you can tell with the vertex when it's written in vertex form or transformation form. So again, when your parabola is written in vertex form, you can just tell what the vertex is by inspection. The x-coordinate of the vertex, it's the opposite sign of what you think. So it's going to be 1, and then what's the y-coordinate of the vertex? -8. So that's the vertex. So there's an infinite number of points on your parabola, but the vertex is a very important one. So that's why instead of calling it x comma y, we can call it h comma k. And so that's the vertex. And this parabola will open upward since a is positive. And this is what I mean by a. This is in generic form. You can write a quadratic function either in transformation form or vertex form, same thing. Or it can be in standard form, which is a times x, ax squared plus bx plus c. That's the one we're more familiar with. But when it's written in vertex form, that's where the a comes from. If a is positive, the parabola opens upward. If a is negative, the parabola opens downward, because that implies a reflection, a negative sign. Okay, so that's a good clue that we know the parabola opens upward. We want to graph this function ultimately. And before we do that, we want to find the vertex, which is very important, and also find the intercepts, which is very important. So let's find the x-intercept. How do you find an x-intercept? It doesn't matter what function you're talking about. You always let y equal 0 and solve for x. So let's do that here. So again, with our original function right there, I'm going to let y equal 0. I put the y on the right-hand side. Okay, so we have this. Finding the x-intercept. Let's solve that for x. You don't need to FOIL this out or expand it out. It's easier if you don't. You could if you wanted, but it's easier if you don't. First, let's get rid of that loose term. Add 8 to both sides. So we have this. And now divide both sides by 2 because you want to isolate your variable x. And when we divide both sides by 2, we get this. Now, immediately take square roots of both sides. Again, don't FOIL that out. And so what's the square root of the left-hand side? X minus 1. And what's the square root of the right-hand side? Don't forget that plus or minus 2. And then by convention, when you have this doohickey, this plus or minus, since I want to add 1 to both sides, you put it in front. It's positive 1, plus or minus 2. These are like terms. Don't stop there. What's 1 plus 2? 3. What's 1 minus 2? Negative 1. And those aren't just any x's. Those are your x-intercepts because we did let y equal 0. Right here we let y equal 0. Okay, we found the x-intercepts. Let's find the y-intercept. How do you find a y-intercept? You let x equals 0 and solve for y. So y equals, instead of writing x, I'm going to write 0 minus 1 all squared minus 8. And again, that just comes right from that quadratic function right here. How do you solve for a y-intercept? You let x equal 0 and solve for y. So that's what I'm doing right here. And let's continue. Let's do this order of preferences, whatever that thing's called. Order of operations. Do the stuff in parentheses first. What's 0 minus 1? Negative 1. What's negative 1 squared? 1. What's 2 times 1? 2. What's 2 minus 8? Negative 6. Where's an ordered pair? 0, comma, negative 6. Because by definition, a y-intercept means that x is 0. Okay, we found both intercepts. That will help us with the graph. In fact, let's start graphing it now. Label your x-intercepts, -1 and 3. Label the y-intercept, which is 0, -6. Our vertex, we found out by inspection, was 1, -8. We know the parabola opens upward since A was positive. So there's a good rough sketch of the parabola. And now we can answer this question. What's the domain? Well, the domain is going to be all real numbers. That's going to be true for any parabola. Notice this right branch. It goes up forever, but also to the right forever. And this left branch goes up forever and also to the left forever. So doesn't that cover the entire x-axis? In other words, I could draw a vertical line anywhere on that x-axis and it will hook up with the parabola, one of the branches. Okay, what's the range going to be? Range always seems a little harder to find than the domain. You really have to look at the graph and think of range just like with domain. It's extremes, lowest to highest. That's how intervals work. What's the smallest or lowest y coordinate? Isn't it that vertex right there? Make sure you choose the y coordinate for range. So -8, and doesn't this go up forever on the y-axis? So that's why it's -8 to infinity. Square bracket around that -8 because that is a point on the parabola. So square brackets. Okay, so that's good. That was a good review. But what about if we have, say, this function right here? Notice it's not written in vertex form. It's written in standard form. It's kind of like ax squared plus bx plus c, where a is always the same as that a. I should really write down the standard form of a parabola. I wrote down the vertex form of a parabola right over here. What does the standard form of a quadratic function look like? Because you can write a parabola in either one of these two forms. I'll write it right underneath it. F of x equals ax squared plus bx plus c, where by convention a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the last number. This comes in handy when you want to use the quadratic formula to solve a quadratic equation for x. And these are super related. I mean, you can get from one form to the other. If you want to go from vertex form to standard form, you just got to square out that binomial, then multiply it by that number, and then add that number to it, and it will look just like this form. And this a will always be the same as that a. That's a good thing to remember. Okay, and in fact, this vertex form, this function here, if I were to square out that binomial, if I square x minus 1, I can do that in my head. It'd be x squared minus 2x plus 1. Then multiply that by 2. So that would give you, let me see, that would give you 2x squared minus 4x plus 2. And then don't forget that minus 8. So then that would be 2x squared minus 4x plus 6, which is exactly my next problem. So what if the quadratic function were this? So again, this is written in standard form, and it is the same function as upstairs, the same one. So we should get the same results here. So how would we find the y-intercept? It's easy to find the y-intercept here. Upstairs, it was a little bit hard. We had to do a little math there to figure out the y-intercept. Let's see. Where did I do that y-intercept up here? You let x equals 0. Oh yeah, I did it right here. I forgot to do this. So right, for that function right there, how do you solve for the y-intercept? You let x equals 0 and solve for y's. So that's what I did right here. So I get y equals 2 times 0 minus, oh, I did do this, all right. Yeah, so let's see if we get 0, -6. So over here, it should be easier to find the y-intercept. You got x equals 0. So what's 2 times 0 squared minus 4 times 0 minus 6? Isn't that just going to be -6? Same thing as we got upstairs. This parabola opens upward because a is positive. What else can we say here? The vertex. It's a little bit harder to find the vertex when your parabola is written in standard form. When it was written in vertex form, it was very easy just by inspection. Oh, the vertex is 1, -8. But here, when it's written in standard form, your quadratic function, you have to think of this formula. How do you solve for the x-coordinate of the vertex? Remember, the vertex is an ordered pair. You need an x-coordinate and a y-coordinate. And here's the formula for the x coordinate of the vertex. I like to write capital V with the subscript of x for x coordinate. Or you could write h. H is the other variable, which is for the x coordinate of the vertex. Your call, either v sub x or h. I like to identify my work. And here's the formula, negative b over 2a. Very simple formula to remember. And let's incorporate that formula to find the x coordinate of the vertex. So what is negative b? Isn't this a, b, and c from the standard form that I showed you a couple minutes ago? So what is opposite b? Wouldn't that just be 4 over 2a? A is 2. What's 2 times 2? 4. So I get 4 over 4, which I have right over here. Isn't that another name for 1? So yeah, I put the negative sign here. Negative opposite b over a. So, okay, we got 1 there. Let's figure out the y coordinate of the vertex. All you have to do to figure out the y coordinate is plug in whatever you get for the x coordinate, which we got as 1, for all x's in the original function. It's kind of like a table of values, same idea. You know, if you want to write it like this, if we let x equal 1, which was what we did get for the x coordinate of the vertex, what is y going to be? Let's figure that out. I'll put a question mark there. It's the same idea as an ordered pair, too. So let's figure out, what do we get when you let x equal 1? Well, we get negative 8. It's easy enough to, when x is 1, it's pretty easy. What's 2 times 1 squared? What's 2 times 1? 2. What's 2 minus 4? Negative 2. What's negative 2 minus 6? Negative 8. So we got the y coordinate of the vertex. So what is the vertex? 1 comma negative 8. Let's find the x-intercepts now. So notice, to solve for the x-intercepts, it looks a little bit different from what we did upstairs when we found the x-intercepts, where we let y equal 0. Look how weird this was, where we did not square out that binomial. We showed good resistance there and we solved it that way. We should get the same answers though of 3 and negative 1, since these two functions are exactly the same, just different forms. One's vertex form and the other is its equivalent standard form. So let's find out the x-intercepts. You got here, when you're finding the x-intercepts, you set equal to 0, which gives you a lot of power when you have an equation equal to 0. You can do whatever you want to both sides. So let's make life easier on ourselves. I noticed the greatest common factor there on the left-hand side is 2. Divide everything by 2. Both sides of the equal sign by 2. You're allowed to do that by the division principle of equality. Remember though, never divide by a variable. You could lose a solution. So these two are equivalent equations, but this looks a lot easier to factor. And let's go ahead and factor that. The leading coefficient's 1. So how do you get x squared? X and x. And then what two numbers multiplies to negative 3 and adds up to negative 2? How about negative 3 and positive 1? Isn't that product negative 3? And what happens when you add up negative 3 and 1? You do get the negative 2. So it's factored correctly. Now let's use the zero factor property to solve for x. And we get x equals 3 and x equals negative 1. Same results as we got right over here upstairs. So let me step away here and try to, just in case you want to look at the whole problem. There it is. And that's about all. So good night, everybody.